Welcome to Chapter 4. Get set up here. So this is Chapter 4. Oops. It's all about alkanes. Now we're really getting into looking at organic molecules in detail. And so we'll kind of go through an introduction here, as usual, and then get into the details. So 4.1 is the intro. And we want to look at what is an alkane. First of all, it's an aliphatic. That's a term we'll use. Aliphatic versus aromatic, but aliphatic hydrocarbons with only CC and CH sigma bonds. So we're talking about single bonds only, carbon-carbon, carbon-hydrogen. That is it, okay? It's the simplest organic molecules that there are. And there are acyclic, and there are cyclic. The molecular formula for acyclic is C to the N H2N plus 2. It's just the formula for the number of, if you have a certain number of carbons, then you're going to have that number of hydrogens. So 10 carbons is going to give you 22 hydrogens. Okay, you'll see this play out. These are called saturated. Saturated and aliphatic are synonymous. Cycloalkanes have a C to the N H2N. There's 2 less hydrogens because you formed a ring. Cycloalkanes actually are a little tricky to categorize because we kind of think of them as unsaturated. It's not fully saturated with CH bonds because of the ring. A ring is kind of like a double bond in that sense, okay? That it is a degree of unsaturation. We'll introduce that term later. So a couple examples here. Hexane. We're going to learn the names here in a minute. Hexane is CH3, CH2, CH2, 6 of them. And the ends have CH3, so there's 6 carbons there. And we're going to very quickly move from these types of formulas to skeletal structures. Those are the same things. Those are equal. Okay, we'll talk about that a little bit more. Cyclohexane is going to be a ring. Okay, 6 carbons in a ring. Okay. C6H14 over here. C6H12 right here. So let's take a step back real quick just to categorize again. That's an example. Again, we have hydrocarbons. Just to give you kind of the big picture view. Okay. We have 2 big categories, saturated and unsaturated. Within saturated, you have, most definitely, you have alkanes. And what I kind of just said a second ago, you have cycloalkanes, meaning there are no double or triple bonds. Some people speak of unsaturation as a multiple bond. Some people kind of put rings into that category. So like I said, it's just not a perfect distinction. But within unsaturated, you have alkenes. We'll talk about those later. Alkynes. And much later, we'll talk about what are called arenes. Okay, these aren't terms that you'll have to define necessarily. You just need to get used to them. So there's cycloalkenes, cycloalkynes, and arenes are aromatic, and they're all cyclo. Okay, so we'll look at those mostly in organic too, but we'll introduce benzene and aromatics. We'll show those along the way. Okay, but really we'll look at the chemistry of those in organic too. Alkenes, chapter 10, I believe. Alkynes, chapter 11, later in this semester. Okay, And so again, cycloalkanes, depending on how you look at it, they do have a degree of unsaturation, we would call it. Now let's introduce another sort of little table like this. Let's introduce a term, isomer. An isomer is a different arrangement of atoms. Okay? The atoms are mixed in a different arrangement. We're going to see that there are two types, constitutional and stereo isomers. Constitutional isomers and stereoisomers. We'll get to stereoisomers in chapter 5. Constitutional isomers are the atoms are in different arrangements. They're moved around, so to speak. Stereoisomers are simply, they have different three-dimensional. They have the exact same connectivity. Okay, so constitutional, you can think of different connectivity. These all have the same molecular formula. Okay, so C to the N, H2N plus 2, whatever. They have the same formula, but constitutional has different connectivity. Stereoisomers have different three-dimensional connectivity. Okay, and so we'll see those as we go. So let's jump back into specific cases now. Let's build up our knowledge here. We have methane. We're going to learn names here. You got to memorize. I'm going to make you memorize 1 through 8. Okay, so we'll start 1 carbon, methane, CH4. It's the simplest. We've talked about this already. Here is the Lewis structure. All of these are different angles of the same thing. So we have Lewis. Again, you can't draw three-dimensional. You can't draw these wedges and dashes that I'm about to draw until you understand Lewis structures. Okay, we talked about the shape, right, of these molecules. Talk about molecular shape. A little bit. Second. All right. So we talked about Lewis structures. We talked about isomers already. We introduced that term, right? We talked about molecular shape and hybridization and all those things back in chapter 1. And so now we're back into that. We're going to look at now the three-dimensional shape of carbon, right? These bond lengths are 1.09 angstroms. Pretty easy to remember, actually. The 1.09 angstroms and 109 degrees, 109.5 degrees is the bond angle. Okay, this bond angle here. So 1.09, 109.5. This is tetrahedral. So important. Okay, bond angles. It's not planar. These 4 hydrogens are arranged around a central carbon. There's 4 equivalent sp3 hybridized CH bonds. Remember, we talked about how each of these each of these bonds is an sp3 orbital, and that H is a 1s orbital. Okay, so go back and make sure you're solid on those concepts. So let's look at ethane. It's the next one, 2 carbons, C2H6. Okay, CH3CH3, if you wanted to abbreviate. Okay, the carbons have to be connected there. Again, Lewis structures. Drawing Lewis structures gets very old, and that's why we're going to move into skeletal structures very soon. Okay, that's the Lewis structure. Here is the three-dimensional. At each carbon now. Okay, 1.09 angstroms, 109.5 angles. Bond angles, this bond is 1.53 angstroms, Okay, so a carbon-carbon bond is a little longer. Again, all sp3 orbitals around that carbon, or each carbon. Okay. Next is propane. CH3, CH3, CH3. Okay, we're going to see very quickly that's the skeletal structure. Okay. Doesn't matter if you draw it like this or like that. Those mean the same thing. Okay. We're going to skip the Lewis structure. We got 3 carbons in a row. And now I'm going to draw this last one. Okay. Again, it is always tumbling. Okay, so there's different ways we can draw this. Okay, it's propane. One isomer only. Okay, we're going to see with butane. That's next. There are 2 butanes. Okay, butane C4H10. Okay, you could draw, I'll show you both of them. I'll draw the Lewis for this so you can really see it. 4 carbons in a row. Always start with just drawing the carbons in a row, whatever chain you have to draw. If it's butane, it's 4. If it's pentane, it's 5. Okay, this is the straight chain of butane, and that is the skeletal structure. This one, however, is different. The carbons, at least some of them, are very different. Focus on that carbon. That kind of carbon simply does not exist in this molecule over here. Okay? We'll talk about this too in a minute. Isobutane is what we call that. So butane, N-butane for normal, okay? The N will get dropped many times, N-butane. We just call it butane. And isobutane, the isomer of butane. There are 2 constitutional isomers, 2 different connectivities. Very, very important concept. This is a branched chain alkane. Okay. All right, let's keep building up. Pentane. I'm spending a lot of time on this because I want you to learn these names. I want you to understand I want you to understand these very, very well. Okay, so pentane has 5 carbons. Let's draw all 3 isomers. C5H12. Always start with the simplest. Let's draw them in skeletal form. 5 carbons, straight chain. Okay, we'll talk about why the straight chain is more stable in a little bit. That's pentane right there. You can draw out the Lewis formula if you want to. Now let's draw out an isomer. 4 in a row, and then put a methyl group as a CH3. Okay, and we'll go over kind of how to draw some of these. Okay, but you need to practice. So I'll give you a practice problem, sort of a take home in a minute. What you kind of do is you're going to walk this down the chain. This CH3 that is implied there is going to walk down. So this is carbon 1, 2, 3, 4. So to speak, we're going to switch an H and a CH3. So now your CH3 is there and your H is attached to carbon 1. Okay, numbering carbons is very, very helpful. Let's put this one as number 5. Okay, it's an isomer of pentane. Here's another one. Now you have a carbon here in the middle. That's a carbon with no H's. It's a quaternary. We'll get into that in just a second. All right, so that's pentane. Let's look at hexane. C6H14, or rather, let's not look at it. I'm going to tell you there's 5 isomers, and you should do problem 4.3 in the book. 4.3 is exactly this problem. Draw all 5 isomers. It's a very good practice problem. That's the maximum number that I will ask you on the first exam, okay, is to draw 5. I'm not going to ask you to draw 15 or anything like that. Okay, so do problem 4.3. Hexane is 6, and we got heptane is C7H16. There's actually 9 isomers. Practice drawing those. That's a good practice problem. I won't ask that in an exam, but octane, right? High octane rating in gas, gasoline. C8H18, there's 18 isomers. It goes up exponentially. Now this is where I'm going to cut off in terms of what I'm going to require you to know. There'll be problems that you should practice with 9 and 10 and 12 carbons, but I'm going to ask you to memorize 1 through 8. Okay, 1 through 8 of the straight chain, and that will help you with all the naming that we do the rest of the semester. Okay, but I want to tell you, just so you know, nonane for 9 is C9H20. There are 35. And then decane, as in deca, you get to 10, 22 hydrogens, 75 isomers. Whew, 75. So FYI, icosane is C20H42. There are 366,319 possible isomers. Okay. All right. So what you need to know is 1 through 8 of the normal. Okay. So practice them. Make flashcards. Methane, ethane, propane, butane, pentane, hexane, heptane, octane. Okay. You also need to know the 2 isomers for butane. You already know one of them, butane and isobutane. Okay. You need to know pentane, and not the names, but you definitely need to be able to draw them. Now, I'll say the only name you have to know for an isomer is isobutane until we get to the alkyls. Okay, we'll explain that when we get there. But you got to be able to draw all 3 isomers for pentane. You got to be able to draw all 5 isomers for hexane and both for butane. Okay, so practice makes perfect. Let's talk about classification of carbon atoms. Okay, another very important concept. Just to be able to speak the language. So let's say there's a carbon attached to one other carbon. We don't know what these are. These lines just mean there's something else attached. Non-carbon is what we're saying. Okay, let's call them hydrogens for now to make it simple. This is a primary carbon. Okay, we're going to have primary, secondary, tertiary, and quaternary. Okay, it's all about the number of carbons it's attached to. Secondary. Oops, that is a carbon, not a chlorine. Carbon, carbon, tertiary. A carbon that is attached to 4 carbons is called a quaternary. This is called tertiary, secondary, primary, and quaternary. Okay, it's just the words we use. Now, it's going to be, this is very important, but it's going to be more important when we talk about the hydrogens that are on there, the types of hydrogens. Okay, it's going to become very important. So let's now look at the same idea. If you have a carbon attached to one carbon and the hydrogens there, these are primary H's. They're on a primary carbon. That's all it means. Primary hydrogens are on a primary carbon. Okay, let's look at a secondary. These H's would be secondary H's. Tertiary carbon, label it, primary, secondary, tertiary. That hydrogen, there's only one of them now, is a tertiary hydrogen. We introduced this with isobutane. Now, what happens when you have 4 carbons around a central carbon? It's a carbon again, not a chlorine. That's a quaternary carbon. There are no hydrogens, so there's no such thing as quaternary hydrogens. Okay. Now, again, you can do the same thing with OHs or NH2s. Any functional group, you can say this is a primary alcohol. Okay. Just replace the H with an OH. We're not there yet. You don't need to worry about it. But you look at the carbon, how many carbons is attached to, that's the type of carbon it is. So whatever else it's attached to, like an OH, it's a primary alcohol, it's a secondary alcohol, it's a tertiary alcohol. All right, so that's just a glimpse ahead. All right, that's an introduction to alkanes. Let's introduce cycloalkanes, okay? Cycloalkanes. The smallest ring you can have is propane, okay? So let's look at cyclopropane. So let's look at propane. This is not what actually happens. We're going to sort of envision making a ring, okay? So basically what's going to happen is we're going to in a sense, mentally, remove these two hydrogens. So minus two H's, and we're going to form a bond now between these two carbons. Okay, so it's got two less hydrogens than propane. This is cyclopropane. Let's just make this line solid. Doesn't mean it's a half bond or anything. Cyclopropane. Okay, so instead of two hydrogens, now we have the carbons connected to each other. This is a triangle. If you were to draw the skeletal, there are hydrogens implied on those carbons. You see a lot of implied carbons and implied hydrogens. The sooner you get used to that, the better. And so you got a triangle, which means cyclopropane. There's two hydrogens on each carbon of that triangle. Okay, you got to memorize these. Again, once you get the first 8 down, the rest is easy. Okay, there's no cycloethane, obviously. There is cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, cyclooctane. Okay? So what do they look like? You can draw the names for these. They're just the shapes. Okay? Once you get past butane, it gets really easy. Okay? Cyclobutane, cyclopentane. Okay? Like the pentagon. Cyclohexane is a hexagon. Cycloheptane, probably the hardest to draw, is a 7-membered ring, the heptagon. And then the little stop sign. Okay, we all know that shape. Cyclooctane. Okay. Let me give you a take-home or practice with isomers. Okay. Do naming in just a sec. So I'm going to give you C5H10. And I want you to draw the isomers. Draw all isomers. I said the maximum I'd give you is 5. There are 5 of these. Okay. I think this is in the book somewhere. Draw all 5 isomers of C5H10. Okay. I'll give you the first one. It is this ring. Okay. And I'll give you a hint that the other isomers are smaller rings. Okay. C5H10. No double bonds, no triple bonds. Can't be a triple bond. There could be a double bond, okay? Rings only, okay? That'll be the caveat. Rings only. All right? 5 of them. All right, so now let's introduce naming. Introduction to nomenclature. Okay, historically, names were given for various reasons, and then they came up with what's called an IUPAC system, the International Union of Pure and Applied Chemistry. Sounds riveting, but it's very important. Okay, they do many things, but one thing they do is they give systematic names to molecules. Okay, so you can imagine. Let's draw one molecule as an example. And this will be good to introduce what's called aromatics. A very common molecule that you may not recognize the structure of if you take a look at that molecule. First things, before we talk about naming, this is an aromatic molecule, or an arene. Okay, the chemistry of which we'll talk about in organic too, but we'll show these types of molecules. It's 6 carbons with alternating double bonds. Okay. And we're going to see that there are resonance forms. I believe we've already introduced this. You could alternate those double bonds all the way around the ring, no problem, and it's the exact same molecule. So you can draw it either way. I'm going to use these as pieces on molecules, so you need to be able to not be thrown off by them. Okay, but they're not true double bonds. They're not alkenes, and so we'll talk about those in much greater detail in organic too. But you should recognize them. Okay, they're aromatics. So the IUPAC name, I'll just tell it to you, is 2,4,2-methylpropanoic acid. It's a mouthful. You can see why there's common names. Okay. The generic name is ibuprofen. Okay. Ibuprofen. ibuprofen. Okay, and the trade name is either Motrin or Advil. Very common medicine if you ever had a headache or something like that, or muscle ache or something like that. And so you have this IUPAC name gives us a systematic naming. Now, we're obviously not going to name things that complex, but we are going to work on naming alkanes, both acyclic and cyclic. So first, let's look at acyclic. 4.4. There is a basic structure to these. Prefix, parent, suffix. Okay, the very first question you should always ask is, what is the longest carbon chain? Longest carbon chain. Sounds simple. It is simple sometimes, but when it'll get a little bit complicated. Okay, so we need to work on identifying the longest carbon chain. So methane, ethane, propane, butane, pentane, hexane, heptane, and octane, right? We said 1 through 8. Okay, the second question is functional group, right? We introduced functional groups in chapter 3. So right now the functional group is alkane, okay? And then thirdly, this is where it gets difficult. The third question is substituents, meaning things attached, okay? And so before we start naming, we've got to look at what do we mean by a substituent, okay? The most common are what are called alkyl groups. Okay, so we introduced alkanes. Now, alkyl groups are simply an alkane minus a hydrogen. So instead of methane, it's going to be methyl, YL. Okay, so let's go through that. And this thing is attached. So what do you have? You have methane. We're going to, quote unquote, remove one hydrogen. Okay, we're not really doing this chemically. We're doing it on paper. But the hydrogen has been taken off, and now it's attached to something. We don't care what that is right now. R is a generic connection. We'll see that used a lot. But this right here is a methyl or methyl. Okay, the same thing can be done with ethane. So just like we have the alkanes, we can have the alkyls. A little sloppy there. That's just ethane. We're going to remove, try to draw a little more clearly, remove this hydrogen here. So now it's attached to some R group, some generic group. This is what we mean by an ethyl. And we'll use skeletal structures too. So methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl. Now it becomes more challenging after ethane though. There's the N chain, so to speak, all right? But then there are isomers of alkyl groups. So just like there was butane and isobutane, once you start removing hydrogens, you're going to have isomers. Okay, there was no isomer of propane, but now let's take a look at this. And this is where the types of hydrogens becomes very important. Let's look at propane. We have two different types of hydrogens. We got a primary. We have 6 of them. Let's circle them. Okay, we're going to remove this one here. Okay, we have 2 secondaries. Let's square them. We have 2 types of hydrogens. Either one, something could be connected to. We're going to remove the primary, and we're going to remove the secondary. Removing the primary gives us. Sorry, I'm removing this one. Doesn't matter. Okay, this is N-propyl, or just propyl. The N gets dropped many times. Okay, got to memorize this. Also, R. 1, 2, 3 carbons attached to some R group. There's an N-propyl skeletal structure for you. Memorize N-propyl and memorize isopropyl. Attached to something, an R group. This is isomer. It's the isomer isopropyl. Abbreviations, you might see NPR, IPR. Okay. Skeletal looks like that. All right, so now we have two isomers of propyl groups. Got to draw this all out and keep practicing. Remember butane now. We had two isomers of butane, N-butane and isobutane. So let's take a look at both. Let's look at N-butane first. Four carbons. We have two different types. We have 6 primaries and 4 secondaries. Primary H looks like this. We're going to abbreviate now. Make it an R group. That is a butyl group. N-butyl. Or butyl. YL. Okay. Let's remove the secondary. 4 different options. They're all the same. Okay, this whole group here is a sec-butyl. A secondary hydrogen was removed. Sometimes you'll see S-butyl for short. Okay, secondary hydrogen was removed. You got to memorize all 4 of these. These are 2 of the 4. Now let's draw. Look at the other one. This is isobutane. There are 2 different types of hydrogens. There's 9 primaries and there's 1 tertiary. Let's remove the primary. What do we have? Put an R group there. Isobutyl. This one's probably the hardest to remember. It's the isomer. It's the isomer of the butyl of the isobutane. Okay, it's the only one that doesn't really make sense because it's a primary hydrogen, but it's from the isomer. Isobutane gives isobutyl. All right. The rest of them are pretty straightforward. Okay. Tertiary hydrogen. This guy, we get a nice symmetrical looking thing. This is a tertiary butyl. It's the only tertiary CH we have. Okay, it's tert-butyl. You'll see T-butyl. Okay, these are very important. You got to memorize all 4 of them. Memorize both the propyls. You got propyl, isopropyl. You got butyl, sec-butyl, isobutyl, tert-butyl. Okay, memorize them, but also think about what's going on. Tertiary hydrogen, tert-butyl. Okay, secondary hydrogen on the first set was a sec-butyl. Okay, the only secondary hydrogen that gets removed, sec-butyl. The only tertiary gets removed, tert-butyl. There's 2 different types of primaries among these 2, and you get butyl and you get isobutyl. All right. So other common abbreviations, just so you know, ME, you might see that. You don't need to know it. That's methyl. Okay. You might see me do that without just out of habit. ET is ethyl. Those are just, they're common. Okay. I gave you the propyls and the butyls. All right. So now let's practice some naming. Now that we've got our prefixes, basically, these are our substituents. Got to practice though. Okay, so I'll either give you the structure or I'll give you the name. So let's give some structures. I'll give it this way, and then mostly it'll be skeletal beyond this. See very quickly that it can get complicated. So let's count our carbons. Let's start from the left. You don't have to start from the left. That's important. 1, 2, 3, 4, 5, 6, 7. That'd be 7. But if you had 6, 7, 8, the longest chain is 8. Let's try this. 1, 2, 3, 4, 5, 6, 7. Okay, there's a couple 7s. 1, 2, 3, 4, 5, 6, 7, 8, or 8. Either way, it doesn't matter. It's because these are the same groups. It's not going to matter. Okay, so it's 8. Now the question is, do we go left to right or right to left? Okay. Well, the first question is octane. Okay, that's the longest. They call it oct. Okay, the suffix is ane. It's going to be ane, but it's oct. Okay, is the longest carbon chain. That's the parent. Suffix, since we're doing alkanes, the suffix is just ane. Okay, so we got our octane. Now we got to do the prefix. Big key with prefix. Big rule. First substituent equals lower number. Okay, so which way gives us the lowest number? If we start from the left, we have a substituent at 2. If we start from the right, we have a substituent at 3. So we're going to start from the left, so let's number it. 1, 2, 3, 4, 5, 6, 7, 8. All right. So where are our substituents? What do we got at C2? We have a CH3 at 2. We have a CH3, CH2 at carbon 5. We have another CH3 at carbon 6. So the first important rule is the first substituent lower number. Then we're going to alphabetize. And this is where it gets complicated. Let me write some rules on the next page. Alphabetize. So let's say first substituent equals lower number. Then we want to alphabetize. But there's some caveats. We're going to ignore all prefixes. Okay, we'll see what those means. The whole thing is a prefix, but there's sort of prefixes within prefixes. Okay, you practice this, you'll get it. Okay, we're going to ignore all the little prefixes like di. There's 2 methyl groups, so we're going to have dimethyl. Okay. Now, the one exception to that, we're going to ignore all little prefixes except for one, iso. It's a big one. I.e. isopropyl and isobutyl. Okay. This is a pain in the butt, I'm not going to lie, but the reason is iso has become a common name or an accepted name, iso in and of itself. Okay. So we're going to ignore iso. Okay. And then you'll see there's numbers and letters are going to have hyphens. You're going to have one number per substituent. Numbers are going to be separated by commas. I don't want to list all that out. I want you to practice. Okay, hyphens and commas are less important, but you'll get the gist. So this one, the name of it is 5-ethyl 2,6-dimethyl octane. Okay, notice the M and the E. That's what we alphabetized. E comes before M, not D before E. The di doesn't count. We'll see lots of examples. We're going to go through some rings. We'll do some examples that way. You should go through the problems, etc., etc. All right, let's wrap up with some cycloalkane names. Okay, there are plenty of problems for you to practice with naming the straight chain alkanes. Go through the how-to, 4.4b. Okay, naming substituents. They walk through propane and butane. Again, all of this is listed out for you in the text. You should look at that and do some practice problems. Okay. 4.7, give the IUPAC name for each compound. Okay, there's plenty of practice at the end. You should be doing all these problems. Okay. 4.5 now is naming cycloalkanes. So these are just rings. Prefix plus cyclo plus parent plus suffix. Let's write that out. Prefix plus cyclo. You got to have that cyclo in there. If it's not there, it's wrong. Got to tell me it's a ring. So let's go through this. Let's do an example. Structure. What's the name? Well, let's start. What's the ring size? It's 5. Okay. So the parent is pent. It's a cyclopent, and we need prefix and suffix. The suffix is ane. Okay. Now we don't need a number on this. Why? Because it doesn't matter. Let's draw it a different way. Oops. Sorry. Let's put the methyl group over here. Doesn't matter. It's automatically the one position, and it's not. You don't want to write it. Okay. Methyl cyclopentane. Methyl cyclopentane. Now let's do one with 2 substituents. Let's draw it another way, just so you can see a skeletal, purely skeletal. Often we write short substituents out. CH3, CH2, CH3. Sometimes we don't. Okay. Now, how are we going to name this? It's ethyl and methyl, and it's 1,3. Okay, it's either 1,3 or the opposite, 1,3. Okay, the 1 is the ethyl position because it follows the alphabet. So the answer is 1 ethyl, 3 methyl. In a ring, the numbers follow the alphabet. Okay, and it's a cyclohexane. A couple examples. Let's do a couple more. Let's look at these 2 together. Now we have a question here. Which is larger, chain or ring? Whichever one's larger becomes the parent. So let's look at the one on the left. The larger of the 2 is hexane. It's cyclohexane, sorry. Cyclohexane. The ring has more carbons. There's 6 here, and there's only 5 here. It's just the way we do it. So it's pentyl. The 5 is the substituent. Pentyl cyclohexane. This one, however, the chain is longer. We want the lowest number of substituents, so it's going to start from the left. And we do need a number because you could have, I'll show you in a second, you could have 2 cyclobutyl. This is 1 cyclobutyl heptane. So let's draw 2 for you. Draw 3 rather. 3 cyclobutyl. You could have the 2 and the 4. Couldn't have 5, 6, and 7 because you want the lowest number. 5, 6, and 7 are 3, 2, and 1 again. Okay. All right. Let's do a couple more rings, and then we'll wrap this video up. And this will introduce our isopropyl exception. Okay. I gave you the substituent. There's an isopropyl. There's a methyl. It's a pentane. It's a cyclopentane. Now we're going to name this as 1 and this is 3. Why? Even though methyl comes before propyl, this is isopropyl, and you don't ignore that substituent. So we have 1 isopropyl, 3 methyl. I comes before M, cyclopentane. Let's do another one where you do ignore. Practice our butyls. Okay, now we have 1, 2, 3, 4, 5. We have a pentane again. We're going to ignore the sec of the sec butyl. This is a sec butyl. A secondary H was removed. So we have 1 sec butyl. We ignore the sec. B comes before I. Okay, get used to the hyphens and the commas and stuff like that. But again, if you switch a hyphen and a comma, it's not the end of the world. Okay, 1-sec-butyl 3-isopropyl cyclopentane. Let's look at some common names. 4.6. Just to remind you, butane is not particularly common, but we'll lump it in there. Isobutane. Okay. Told you you'd have to draw these. This is pentane. You don't really need to know the names of this. Just to reiterate, this is isopentane, and this is called neopentane. Okay, these two you don't need to know the names, but you've got to be able to draw the structures. No names, no common names, okay? Substituents, propyl, isopropyl. Common / must be memorized. Butyl, we're just reviewing our isomeric alkyl chains. Isobutyl. Sec-butyl. Tert-butyl. Okay. So 4.8 is physical. 4.7 is fossil fuels, very interesting natural gas composed largely of methane. Petroleum is a complex mixture of hydrocarbons containing 1 through 40 carbon atoms. Okay, those are refined into things that are usable. Okay, you've obviously heard of gasoline has a high octane rating. Kerosene and diesel fuel are all just different amounts of hydrocarbons. Okay, so there's a picture of a barrel of crude oil. It's pretty interesting. And then physical properties. Okay, just to review, you should review 4.8. Van der Waals forces, dipoles. Alkanes only have van der Waals. So look at melting point, look at boiling point. You should be able to review that. Look back at section 3.4, I believe. And then next time we're going to get into conformations of alkanes. Very important concept. And so that wraps up this this video.